To appreciate how data moves between computers, we have to understand the idea of what I'm going to call a frame. Data is moved from one computer to the next in discrete chunks. These chunks, which store roughly about 1,500 bytes of data each, are known as frames. Now, to make a frame work, what I'm going to do is I'm going to have a bunch of coffee beans here, which is my data. Now this data might be a Microsoft Word document, or a print job I want to send to a printer, or it might be some email, or it might be a web page. I don't know what's in here. But if I want to move data from one computer to the next, I've got to break it up into individual frames. So now software is handling this in the computer, but on my network card itself, individual frames are being loaded. So I put some amount of data in there. It doesn't have to be 1,500 bytes. Sometimes data is really tiny and only needs a few bytes, but it can't be any more than 1,500 bytes. Oh, by the way, if it's more than 1,500 bytes, you're going to need more than one envelope. So what I'm going to do is I put the data into the envelope, and now this data is ready to be sent. Now if you look at this for a moment, you go, Mike, how can we send a physical envelope through a piece of wire? Well, you can't, but what you can do is something like this. Let me show you what a frame really looks like. You ready? Beep, 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 beep. Okay, that is a frame. A frame is really nothing more than a series of ones and zeros. There's a number of flashes at the start that wake up the cards saying, oh, here comes a frame. Then the data comes in, and then there's a ending part that says, okay, it's all done, and it uses it to check itself. So this discrete chunk, this frame, is the cornerstone of everything we do in the world of networking. So a frame is really binary data. If it's on a piece of fiber optic cable, it's ones and zeros. If it's on a piece of copper cable, it's voltages going up and down. If it's wireless, it's frequencies being changed. But the bottom line is these are nothing more than ones and zeros that are being sent out from network cards and being picked up by network cards. The trick is this. If I've got a network like I have right here, and by the way, this little box in front of me is called a hub, I've got 4 computers hooked to it. Now the problem is I want to send data to only one of the computers. The important thing to remember about a hub is that it's a repeater. A computer sends a frame into the hub, it reads that frame, and then it makes multiple copies of that frame for every other connected port. So in this case, I got 3 connections, so it makes 3 perfect copies of the frame that just went in, and it sends those copies down the wires to every other computer on the network. So how do I know how to get this packet to the right computer? To do that, we need something called a MAC address. Now, if I want to join a network, all I have to do is get myself physically connected to the hub itself, and I'm part of the network. Now, there is a MAC address burned into this network card. That MAC address comes from the manufacturer. The first half of a MAC address, and MAC addresses are always 12 hexadecimal values separated into pairs. So the first 6 characters are actually assigned to a particular manufacturer. If you get good at this, you can actually get to the point where you start recognizing the first half of addresses and go, oh, that's an Intel, or ooh, that's a D-Link, or whatever network card it might be. So what I want to do now is I want to actually send out a piece of data on my network. So I take my frame, and at the beginning of the frame, I just write it on the envelope here, but actually at the beginning of the frame electronically, I put the MAC address where I want it to go to, or what we say the destination MAC address, and then I put the source MAC address, or the from. I put my own MAC address on it. So what will happen is that this will then get propagated out, and it goes to all the different computers on the network. Let's watch that happen. Now this time we go ahead and we send the frame with the MAC address information on it. The hub makes as many copies as necessary and sends them back out to all the computers on the network. The important thing to understand here is that every computer gets a copy of that frame. Ooh, I've got mail. When a computer receives an incoming frame, it has to look at that frame, and it looks at the to part of the MAC address, compares it to its own MAC address, and decide whether it's for him or not. If it's for him, he goes ahead and he sends it up into the software, into the operating system itself. And if it's not for him, at least the idea is that he just erases it. Now this is kind of interesting because with a hub, because every frame that comes into the hub is propagated out to every other computer, you could actually set network cards up into a mode that basically says, listen, even if it's not your MAC address, go ahead and keep a copy. And it's used for network sniffing type situations, whatever it might be. Now, there is one other type of address I want to show you real quick. And that's this right here, all Fs. This is a broadcast address. A broadcast address is a little bit different than a regular address. In this case, when it's sent out, it goes to every other computer, just like we saw. But the big difference here is that when it comes into this computer, when he sees those all Fs, he automatically sends it up to the operating system. These, what are known as broadcast addresses, are never ever deleted. So basically, anytime you have a group of computers that are connected in such a way that they can hear each other's broadcasts, we have what is known as a broadcast domain. And that's really important. Anytime you can do something where you can send out a broadcast and every other computer can hear that broadcast, that's a broadcast domain. So, what I want to do now is I want you guys to appreciate that there's some problems with the hub. The biggest problem we have with the hub is that the speeds of hubs have been, well, 10 megabits per second, 100 megabits per second, 1 gigabit per second, and even now 10 gigabits per second. But the problem is if I have 3 or 4 or 8 or 27 computers hooked to that one particular hub, every 2 computers that are talking to each other eat into the bandwidth. So if I have a 100 megabit per second hub and I've got 4 computers and they're all talking at the same time, in pairs, I in essence have dropped the bandwidth down to each connection to only being 50 megabits per second. So this was a big problem with a hub. So we got around it by doing something very clever. We got rid of hubs. I so wanted to throw that, but not in my own kitchen. And we replaced it with a switch. So what I want you to do, guys, can you hand me that blue cable, please? Thank you. So I want you to take a look at this switch. Let me bring the hub back. Top one is a hub, old technology, ancient, hardly used anymore, and the bottom one's a switch. Basically, it's hard to tell a hub from a switch just by looking at them. The secret is that switches are very, very smart. And I want to show you how switches take advantage of MAC addresses to make computers run much, much faster. A switch is very different from a hub because it's smart. It actually keeps track of the MAC addresses of the computers that are hooked to it based on ports. So in essence, it keeps a little sheet of paper that stores the port number and the associated MAC. So in this case, what I want to do is I want to have the computer on the gray cable talking to the computer on the red cable. So if we take a look at the MAC addresses, just looking at the last digits, we see that 66 wants to talk to 8F. So as he begins to send the frame down to the switch, we'll see that the moment it gets to the switch is going to take a look and compare the destination MAC address, where it's going to determine which port to send it back out on. And it sees, there's a perfect match, and that's port number 8. So it sends it out onto the red port, and it goes only to that computer. The other 2 computers on the network, on the blue and the yellow cables, they don't even see this frame at any time at all. The cool part is that if the 2 in the middle were talking, they would be able to work at the full bandwidth of the switch as opposed to cutting it in half as we'd see with the hub. Switches are obviously the way to go, and they're far better than hubs. As a result of that, you really can't even find hubs anymore unless you find some old one on eBay or something like that. So pretty much everything today is switches. However, there are situations where we do have to send out certain types of frames that everybody needs to receive. Remember good old broadcast? Switches still are broadcast domains. Let me show you what happens when we have a broadcast with a switch. Switches handle broadcasts just like a hub does. The moment a broadcast frame gets into the switch takes its notation and basically throws it out the window. And it goes ahead at this point and acts like a hub, makes multiple copies, and sends it out to everybody else. The big goal of this episode was to make sure that you understood how networks use MAC addresses to communicate with each other. We understand now that data is transferred in discrete chunks called frames, and that we use some type of centralized device, either a hub or a switch, to act as a repeater for that data. Remember, hubs and switches may look the same, but hubs are dumb. They're just a repeater. Anything that goes into one port is repeated out to all the other ports. Switches, on the other hand, memorize all the devices that are connected to them based on MAC addresses, and in essence create point-to-point connections between any two devices that are talking to each other, and that way taking advantage of the full bandwidth of your network.